Developed as a means of replacing steam on the extensive electrified network of the southern region, the Class 71, originally known as the HA, would power some of the network's most notable freight and passenger trains, but quickly found that their solely electric nature and a constricting market would rob them of their primary roles, especially following the arrival of the diesel-electric Class 73s during the 1960s. While the Class 74 came about through the fitting of a small Paxman diesel engine to several members of the Class 71 fleet in order to give them the flexibility of the Class 73, this would not be enough to ensure the longevity of the combined classes, and by the end of the 1970s, these once flagships of the southern region were facing their final demise as units, diesels and electro-diesels continued to occupy their ever-decreasing roles. The Class 71 story begins with a problem the southern region had been concerned about since the 1930s, how to translate its hugely successful suburban third rail practice into a reliable long-distance heavy-duty system for the Kent main lines, as for decades, third rail DC electrification had proved itself on inner suburban and medium-distance routes where frequent stops, relatively light trains and dense traffic played to its strengths. However, taking that same system out onto the exposed, more strongly graded and often curved main lines of Kent posed questions of power, reliability and operational flexibility that were not so easily answered, with steam, which still dominated long-distance and heavy freight work well into the post-war years, being expensive in coal and labour, filthy in terminals and tunnels, and increasingly out of step with the traffic the Southern wanted to court in this new era. This included boat trains to the channel ports, dense commuter flows from the Medway towns, cement, coal and aggregates, and fast parcels and newspapers for London and the coast, while at the same time, it also demanded a support infrastructure of sheds, coaling stages and water columns that looked increasingly anachronistic beside modern electric depots and multiple unit stabling yards. Electrification had already transformed the suburban network, bringing higher speeds, faster turnarounds and more frequent services, but the longer, hillier Kent routes needed something more muscular than multiple units alone, and on some of these lines, gradients were stiff and sustained, and traditional steam-hauled trains were already working close to the limits of what was comfortable in terms of timing and punctuality. Operating planners knew that replacing such trains with fixed-formation EMUs was not always ideal, where heavy boat trains, loose-coupled freights and mixed traffic diagrams were involved, while during the wartime era, the Southern Railway mainline electrics, later the Class 70, had already demonstrated in service that a higher-power third-rail locomotive fitted with a flywheel booster could be made to work over long distances and across gaps in the live rail. These were, in effect, a proof of concept for mainline third-rail traction. With these machines and the operational lessons they generated in day-to-day use, including how they rode, how they behaved in poor rail conditions, and how crews managed their power over banks and through junctions, being the direct ancestors of what became the Class 71 and form much of the unwritten background to their specification. By the early 1950s, British Railways and the British Transport Commission were sketching out, in increasingly concrete form, what would become the 1955 Modernisation Plan, this being not simply a shopping list for diesel and electric traction, but a statement of intent about how the nationalised railway network should compete with road and air travel in the late 20th century. And for the southern region, whose suburban and semi-fast electrification was already its calling card, the Kent Coast electrification emerged as its headline project. This would be a visible, prestige scheme that would showcase modern traction and rolling stock to holidaymakers, cross-channel passengers and commuters alike, with the scheme being authorised in 2 phases and engineered for high-capacity commuter and principal mainline traffic to Dover, Ramsgate, Margate and the Medway towns, with major re-signalling, new substations and upgraded civil engineering all tied into the programme. The engineering choice to retain 650 to 750 volt DC third rail was conservative in appearance, but rooted in sound practice and careful costing, with the region already having depots, trained staff, maintenance techniques, and a large existing fleet of third rail EMUs and locomotives, while changing to overhead AC would have meant rebuilding clearances through tunnels, under bridges and past platforms, with all the disruption that implied, as well as running 2 incompatible systems side by side for many years. On heavily constrained alignments and under low structures, gantries and wires would have been difficult and expensive to install, while by contrast, a further extension of the proven DC system could be achieved with relative simplicity and with fewer unpleasant surprises for the engineers and operating departments. What the plan did require, however, was a small but capable fleet of powerful locomotives to do the jobs multiple units were ill-suited to undertake, These including the heaviest passenger turns, prestige Pullman and ferry services that required conventional coaching stock with through international vehicles, newspaper and parcels trains feeding London and the coastal towns during the small hours, and the unfashionable but essential overnight goods and mineral trains that kept industry supplied. Multiple units excelled at regular stopping or semi-fast services with frequent station calls, but they were less flexible when it came to marshalled formations, through coaches, or the varying loads of freight and parcels, and the southern region, therefore, envisaged a mixed-traffic electric locomotive from a very early stage of its planning, one that could be deputized across several traffic sectors as timetables and flows evolved. The basic specification was written into the scheme years before the first locomotive appeared on the drawing board, and in essence, planners were asking for the electric equivalent of a good all-purpose mainline steam type, but one that could also exploit the advantages of electric traction, including high acceleration, sustained high power, and lower routine maintenance. There were two further considerations that shaped the design, and were much discussed by the Southern Region engineers and operating staff, with the first being gapping, with third rail districts being inevitably punctuated by neutral sections, points and crossings, conductor rail gaps through complex junctions, and, on occasion, short unelectrified stretches, all of which meant a locomotive could briefly be isolated from the live rail. On a heavy train, especially when climbing or restarting, a momentary loss of power could have stalled the whole service at an awkward spot, blocking junctions or tunnels, and causing delays right across the service pattern, with the Southern Region's answer, borrowed and refined from the older mainline electrics, being a motor generator and flywheel booster set, which was kept spinning at speed and smoothed the power supply by ironing out voltage dips and bridge-short dead sections. The presence of the booster also had important implications for handling and train control, as because the motor generator set could regulate current of traction motors more delicately than simple resistances, it gave very fine control at low speed, this being invaluable when shunting, easing heavy trains to a stand on tight timing margins, or creeping over complicated point work where adhesion might be marginal in wet or leaf-fall conditions. Drivers who had used the earlier locomotives spoke well of the way the booster allowed them to feel the train, and the designers of the Class 71 were keen not only to preserve that advantage, but improve on it with more refined control gear and greater capacity. The second consideration was safety in yards and depots, as the very places where locomotives spent their time shunting, including Hithergreen, Ashford and yards such as Snowdon Colliery, were full of ground staff coupling and uncoupling stock, walking between vehicles, and working close to the running lines, with live rails in such environments being a constant and very real risk, particularly at night or in poor weather. Although much Southern Region stock later acquired the distinctive high-level brake pipes and control jumpers that kept vital connections clear of the live rail, there were still many locations where having an energized conductor rail in amongst the point work was judged unacceptable. The region therefore planned pockets of overhead DC in selected yards, energized at the same voltage as the third rail to simplify equipment, and specified a compact retractable pantograph in the new locomotives so it could work there with the third rail switched off entirely, with this overhead equipment not requiring to be of mainline catenary standard, but instead tram-style contact wires were sufficient for the low speeds and restricted extents involved. When not in use, the pantograph would nestle into a shallow recess in the locomotive's roof to keep it within the tight southern loading gauge, with this arrangement offering a neat and economical way to remove the hazard of a live rail under the feet of shunters, while still allowing the locomotive to maneuver heavy trains about the yard, while combining this localized overhead provision with the wider third rail network meant the Southern was already thinking in hybrid terms well before the first Class 71 turned a wheel. The new locomotives were conceived as Bobo machines, with each bogie carrying two powered axles, and they sat on a rigid load-bearing underframe with a non-structural body mounted above it, with this approach meaning that the heavy mechanical and electrical components were supported by a strong chassis, while the bodywork itself could be treated largely as weatherproof cladding. In practical terms, it made maintenance and later modification far more straightforward, because major items could be removed, replaced or rearranged without having to disturb the basic structure of the locomotive, while the engines rode on relatively long wheelbase bogies with 10 foot 6 inches between axles and 4 foot spoked wheels, a combination intended to give good riding qualities at higher speeds, to reduce hunting oscillation on straight track, and to spread axle load acceptability on some of the more lightly laid routes in Kent and the inner southern region. 4 English Electric 532 series traction motors were fitted, one per axle, a layout that gave a continuous rating of around 2,300 horsepower and a 1-hour rating of around 2,550 horsepower at the rail, with power being transmitted through suitably geared drive to the axles, balancing the need for brisk acceleration against the requirements for a respectable maximum speed, with starting tractive effort being in the region of around 43,800 pounds-force and maximum speed was 90 miles an hour, figures that put the class well into the mixed traffic mainline bracket. The detailed design was in the hands of British Railway's own engineering staff, drawing on earlier Southern Railway electric experience and on advice from industry, with electrical and mechanical equipment being sourced from English Electric and other specialist suppliers, while the overall integration was managed in-house, with Doncaster Works being chosen to build the class, reflecting BR's policy of spreading the new diesel and electric work around its main workshops and maintaining skills across the system. Construction ran from 1958 to 1960, during which Doncaster turned out 24 locomotives in a steady programme, alongside other commitments, with the original number series being E5000 to E5023, though in service this caused paperwork tangles with other number ranges and did not sit comfortably with the emerging national numbering policies, and as a result, in December 1962, the Pioneer E5000 was renumbered E5024, leaving the class thereafter as E5001 to E5024. The first members of the class were completed in time to appear on test and trial workings in 1958, initially on relatively prosaic freight and parcels turns while drivers, secondmen and maintenance staff learned their ways, with these early outings allowing engineers to observe the locomotives in service conditions without the pressure of headline passenger duties, while early running concentrated on the eastern section, where the new Kent Coast electrification was being energised in stages and where there was a ready supply of suitable test trains. Acceptance tests probed not just basic performance, but also how the booster equipment coped with real-world gapping at context junctions and through-point work, and how the locomotives behaved with long, heavy trains on the stiff banks out of London termini and away from the North Downs, with particular attention being paid to the smoothness of power application, braking behaviour, and any tendency to wheel slip in poor rail conditions. Contemporary accounts and later technical summaries agree that acceleration was extremely brisk, even with substantial loads, and that the locomotives were comfortable with 700-ton passenger formations and freight up to about 900 tons, very much in line with their original design brief. By 1959, the type was in regular traffic, and their entry into full service coincided neatly with the opening of the Kent Coast electrification in its two main stages, with the HAs quickly becoming associated with the prestige Kent Coast Expresses, and passengers soon became accustomed to the sight of a green Bobo electric at the head of the principal trains, hauling the heavy Golden Arrow Pullman and the international Night Ferry sleeping car service between London and Dover, making full use of their high power and quick starting on tightly timed schedules that demanded both speed and reliability. At the same time, they handled fitted freights and continental wagons to and from the Channel ports, coal trains from the Kent pits, and general merchandise to the new marshalling facilities at Hither Green and elsewhere, while on summer Saturdays they might have been found on heavily loaded holiday extras, while in the quiet small hours they worked mail and parcels trains across the region. Mechanically, they proved sound, with routine examinations showing little untoward wear, and major overhauls were straightforward thanks to the underframe-based construction, with maintenance costs being lower than for equivalent steam diagrams and compared favourably with contemporary diesel classes, while the basic electrical equipment was robust and well understood by depot staff after initial bedding-in periods. Their limitations were more operational than technical, as because they were pure DC electrics, they were wholly dependent on the third rail or on the limited areas of overhead yard wiring, and while the booster's flywheel allowed short movements off the juice, meaningful trips over unelectrified branches or diversionary routes was beyond this limited performance, and as the southern region later discovered, this was a major handicap at night, when much freight was scheduled, but engineers also wanted large areas de-energized for track work, renewal of conductor rail or rebuilding of substations. Freight planners and operations staff sometimes had to thread circuitous routes simply to keep a HA on the juice, or else substitute diesels altogether, and these competing demands would later help define the fortunes of both the HA and the electro-diesel locomotives that followed, as the railway moved towards traction that could operate more flexibly when the electric supply was unavailable or simply not provided. By the mid-1960s, the ground was shifting underneath the class in several interconnected ways, with the Kent Coast scheme having brought with it a substantial fleet of electric multiple units for the surging commuter and long-distance passenger business, and as the decade wore on, more and more duties were handed over to EMUs that could be split and joined, turned quickly at terminals, and diagrammed with great flexibility. The HA's regular passenger work, therefore, contracted as new timetables were introduced, until, on a typical weekday in the late 1960s, they were largely confined to the prestige continental services and certain newspaper and parcels trains, with only odd occasional passenger turns when diagrams or rolling stock availability required it, while at the same time, freight on the southern region was starting to decline in both volume and variety as traditional wagon load traffic ebbed away and block trains and containers began to reshape the pattern of flows. The arrival of the versatile Electro-Diesel JA, later known as the Class 73 from 1962, offered managers a locomotive that could do much of the HA's work, but was not helpless when the power was off, and which could also wander more freely onto other regions or unelectrified branches without elaborate planning. And in an era of tightening budgets and pressure to simplify, this kind of flexibility was immensely attractive, and it inevitably pushed the pure electric fleet further into the background. The result was that, despite their generally good mechanical reliability and modest maintenance costs, 10 of the 24 HAs were declared surplus and placed in store as early as 1964, a surprisingly early date given that some of the locomotives have been in traffic for only 4 years, with these stored machines being often kept in apparent serviceable condition, but they represented spare capacity that could no longer be justified purely on Kent Coast work. At the same time, the growing appreciation within British Rail of what a dual-power locomotive could do in areas prone to engineering blockades and short non-electrified branches to docks and yards suggested that stored locomotives might form the basis of something more useful than a reserve pool, and in combination with the underused, relatively modern electric locomotives and a demonstrable operational need for electro-diesels, set the stage for the next chapter. In the mid-1960s, the Southern Region and British Railways Board decided to follow the broad pattern of the successful Class 73, but to do so by rebuilding some of the laid-up Class 71s rather than commissioning a new design, a decision shaped as much by financial constraints as by engineering ambition, with the work being initially expected to take place at Eastleigh, which had long experience with Southern electric traction, but the demands of new multiple-unit construction for the Bournemouth electrification saw the contract diverted to Crewe Works, where capacity was available and expertise with complex rebuilds was well established. There, the stored locomotives were stripped virtually to their frames, their non-structural bodies strengthened internally, and refitted with a Paxman Ventura diesel engine and associated generator, while retaining a single booster set and the existing third rail equipment, with extensive rearrangement of internal equipment being required to accommodate the new machinery, and there were detailed changes to cooling, exhaust, and access arrangements that subtly altered the appearance of the locomotives. The resultant HBs emerged in late 1967 and mid-1968, numbered E6101 to E6110, and were still essentially Southern machines in outline and bogie design, but with a very different operational role ahead of them, with these new locomotives gaining Buckeye couplers, high-level bagpipe jumper cables, and roof-mounted air horns, reflecting their intended work with EP braked coaching stock and TC units in push-pull mode, and signalling that they were now to be regarded as frontline mixed-traffic engines rather than specialists tied to a single corridor. The plan was that these rebuilt locomotives would revolutionize the operation of boat trains and other long-distance services that strayed beyond the third rail, smoothing out awkward locomotive changes and making better use of paths on busy main lines, with Southampton and Weymouth being the main targets, partly because of their importance for cross-channel and liner traffic, and partly because the gaps in the electrification there were particularly inconvenient. Boat trains between Waterloo and the ocean liner berths at Southampton Western and Eastern docks, and also between Waterloo and the Channel Islands and European ferries at Weymouth, had hitherto required locomotive changes at Eastleigh or Bournemouth to attach a diesel for the unelectrified legs, including the street-running tramway to Weymouth Quay, where overhead clearances and local conditions made third rail electrification impractical. With the HBs, the idea was that a single locomotive could run from London on electric power, switch to diesel to reach the docks or quay, and then return to the electrified main line without a break of journey, thereby saving time, reducing the number of locomotives and crews involved, and simplifying operating procedures. And in theory, this would allow British Rail to advertise faster, more seamless journeys to and from ships, and would free up other locomotives for redeployment elsewhere on the network, making the most of a relatively small but highly capable fleet. In service during the remaining years of the 1960s, that vision was only partially realized, and reality proved more complicated than the planners had hoped, with the first HBs, later known as Class 74, working under its own power from Crewe to Stewart's Lane in November 1967, a notable milestone that demonstrated the basic soundness of the conversion work, and through 1968 the fleet filtered into traffic on the southern region as more rebuilds were completed and accepted. The 74s did indeed appear on their intended boat trains from Waterloo to Southampton and on through portions to Bournemouth, where Class 33s often took over for the Weymouth leg, and they shared in mixed traffic duties, handling parcels and mail and some freight alongside the existing Class 73s in a pattern of work that was still evolving at the end of the decade, but teething troubles with the complex electronic control gear and the Paxman diesel engine soon began to colour their reputation, with fitters and crews reporting intermittent faults that could be difficult to trace and time-consuming to rectify. Although on the third rail there were lively performers, whose constant current control gave smooth starts comparable to the HAs and allowed power to be applied right up to the limits of adhesion, their diesel performance was modest, and maintenance of the new systems proved challenging even before the decade was out, and the very sophistication that had promised so much flexibility made them more sensitive to faults and required a level of diagnostic effort that was not always available in busy depots, and those early years set a pattern that would follow the class into the 1970s. Meanwhile, the remaining 14 HAs, later known as Class 71s, continued to work through the late 1960s, but on an ever narrower front with a growing sense that their best days were behind them, and with 10 members of the class away at crew for rebuilding and no new work coming in, they were concentrated on the Kent Coast electrics they knew best, including the Golden Arrow and Night Ferry, the Victoria to Dover and Victoria to Ramsgate newspaper and parcels turns, and a diminishing pool of freights that could be relied upon to remain on the electrics throughout and to avoid lengthy overnight power shutdowns. For operating staff, this meant that diagrams had to be drawn more tightly around electrified routes, and any disruption to the power supply could leave a 71 marooned or in need of assistance, where an electro-diesel could simply lift its shoes and continue on its engine, while engineering possessions and the growing dominance of dual-power locomotives meant that diagrams increasingly favoured the more flexible electro-diesels, pushing the surviving pure electrics into a small set of niche workings where their high performance could still be exploited but their limitations could be managed. For the Class 74s, as more 4-rep units entered service in 1973 and 1974, the through Waterloo to Weymouth passenger turns that had been a mainstay of the 74s were progressively handed over to all EMU operation, with this being operationally efficient and modern, that it removed one of the key diagrams that had justified the class, while the electro-diesels were pushed further towards nocturnal and secondary duties, including Southampton boat trains, Weymouth and Bournemouth night mails, and a selection of freights, engineers' trains and interregional services, where their ability to run on diesel for short distances remained useful but not indispensable. They still ventured regularly onto London Midland and Western Region metals on freight and parcel work, often taking over for a mainline diesel at Clapham Junction or elsewhere, and working forward under the third rail before dropping back to diesel again for the final legs into yards, docks and depots, and on the right day they could still be seen in the London area in daylight, but their world was gradually shrinking into darkness and the margins of the timetable. Despite this varied employment, the class never quite shook off its reputation for unreliability, with a sophisticated electronic traction control that in theory allowed them to apply power very near the adhesion limit, also providing an array of failure modes unfamiliar to depot staff trained on more conventional equipment, while the Paxman engines were noisy, temperamental starters and not especially robust in extended service, especially given the stop-start nature of some duties. Confidence in the class was undermined by a succession of failures on diesel, which was particularly unwelcome on mainline duties west of Bournemouth, or on the street-running line into Weymouth Quay, where a stalled train could cause disproportionate disruption, while there were also instances of difficulties in restarting the engine after a period on electric power, which further eroded trust. In consequence, operating practice shifted over time, and Class 33s increasingly covered the diesel portions of Weymouth boat trains, with Class 74s either turned back at Bournemouth or allocated to duties where their diesel mode was only needed for short, low-risk stretches, such as the short branch into Southampton's western and eastern docks or brief unelectrified sections in yards. By 1976, both classes were clearly vulnerable to a changing railway, and the first of the 74s, 74006, was withdrawn after a serious fire which rendered it beyond economic repair, while 1977 brought further attrition, with 74002 being badly damaged in a collision and 74009 suffering a major failure. At the same time, British Rail had just demonstrated that, with the aging AC electric classes on the West Coast Main Line, that it was willing to invest in re-equipment and modernisation of troublesome electric locomotives when a clear strategic need existed, but for the 1074s, there was no equivalent long-term case, with their principal work declining, their reliability being suspect, and the southern region already having a successful electro-diesel in the form of the Class 73, which could cover most of the same duties with fewer complaints. For the 71s, the end came swiftly, decisively, and, from an operational planner's point of view, tidily, as although 2 members of the class were stopped at Ashford awaiting repair, there was no extended piecemeal rundown in which old locomotives lingered on minor duties, and instead, as part of a wider rationalisation of Southern Region motive power, and the introduction of a new timetable which made more intensive and efficient use of the 73 fleet and of EMUs, all 14 surviving Class 71s were withdrawn together on the last day of 1977. The remaining 7 Class 74s outlasted the 71s in nominal terms, but only by virtue of languishing in sidings and depots once their work had gone, with the last revenue-earning turns being during the second half of 1977, including the famous Class 74 farewell rail tour in December of that year, which itself was delayed by a diesel failure that rather neatly summed up the class's checkered fortunes. All were officially withdrawn by the end of 1977 and were gathered at Eastleigh, where for a time they still looked presentable and almost ready for traffic, lined up nose-to-nose with Class 33s and 07s, but with no future paths or diagrams ahead of them, though one locomotive, 74010, was given a brief stay of execution and was towed to the Railway Technical Centre at Derby for possible departmental or experimental use, its mixed capabilities attracting the interest of engineers who wondered whether the traction package still might have something to offer in a test role. After evaluation, however, it too was condemned as unsuitable, and any thought of a preserved or departmental future for the class evaporated, with scrapping following over the next few years at various locations, and the last to go was 74005, which was cut up in January 1981, bringing the Class 74 story to a definitive close. From that mass withdrawal, just one locomotive, E5001, later 71001, was selected for preservation as part of the National Collection, and will be returned to traffic during the late 1980s and early 1990s to haul various rail tours, though today the locomotive has since been placed on static display and now resides at the Shildon Locomotion Exhibit in County Durham, where it has been restored to BR Blue. Taken together, the histories of the Class 71 and 74 chart both the ambition and the compromises of Southern regional electrification in the post-war years, including the desire for powerful electric traction, the ingenuity of electro-diesel conversion, and the eventual triumph of more flexible traction and multiple unit operation, and in this context, the class, from their original inception, ultimately never found their usefulness fully exploited, but would prove to be a robust component of the Southern region's roster for nearly 20 years.